So I think if you have ever worked on building a SaaS platform or SaaS product, one of the things you always have to, you know, always get to and is how you scale it forward for users. So initially you have this number of users, but as your product grows or your applications, is being used by more users, how do you build it for more? How does the application scale for the number of users that you might have? So I think some of us might have some idea, like some people say move to microservices, use, on, scale, do horizontal scaling or vertical scaling. But then is that it, or is there more to it? So that's what we're going to look at today. Before that, a brief introduction about myself. So my name is Pratish. I have worked in the cybersecurity domain for the last 10 years. I worked at a company miniOrange. We had an AISA IAM Solution, but then we catered to other Bitcoin products. So you have a SaaS platform that we have built from scratch. So we had a lot of insights. I have a lot of insights over the past 10 years, which I'm going to share today. It probably might help you guys if you're building your own applications. So with that, first question that's capitalized is, why do we need to scale? Like, I think some of them I mentioned earlier. Obviously, to increase the load, the number of users, the traffic, you want to make sure your application is always available. It does not go down, and it's not very good user experience. So you want it to be up, the 99.9% availability that usually the SLA that just goes out to your end users. You want to make sure your app is up, because if the app is down, because you start losing your users, you start losing your customers, right? And also, if you are doing a global scale out, let's say or we're targeting one region and not move to another region, and you want to target a lot more users. So with that, those are the reasons why you need to speak. So I take the questions that I think everybody understands that. So let's look at a Google's definition of what is scalability, right? So if you type in what is scalability, so it will say something like cloud scalability in cloud computing refers to increasing or decreasing IT resources as needed to meet changing demand. So what did that? So is it just IT resources? So that's what we'll be looking at. Usually you'd come across the second link which says you need to do vertical scaling or horizontal scaling, right? So what does that mean? So vertical scaling is just a quick overview for people who probably don't know, but it's increasing your resources for like if you have the laptop, you want to increase your RAM or CPU, if every year you upgrade the laptop to the newer version, it's getting more CPUs, more RAM to be able to perform more actions, right? So it's similar to that. Horizontal scaling is more about getting multiple laptops or multiple servers, which can simultaneously or parallelly work, and you can get multiple tasks done at the same time, right? So that's vertical and horizontal scaling. So is that it? So, does that you like, let's just add more servers or increase the CPU or increase the RAM, and then we're good, and that will solve it. That solves scalability and or such. Is that it? Not exactly. So the main question is it that simple? We just add resources or increase the resources that we already have, and that solve, discover all of our problems? Or is there something more? So adding service does not always solve the problem. You might have some issues with your application that you should look at, because adding more service might add to your problems in many cases rather than actually solve it now. And obviously, there's a big question of cost. You can't keep adding more servers. You don't want to end up having, if you're on AWS servers, you don't want $1 million, bill at the end of a year. But it's all fun. So you always want to be efficient where you can scale while also keeping the cost down. So with that, a little bit of context. Let's jump right in and let's look at what scale looks like on somebody who has actually scaled an application. Let's just jump right in. So let's look at that, or let's tackle horizontal and vertical scaling again. So what are the upsides to it? So let's say you have an immediate need, you can add more resources, and that should solve your problem. But that will be a temporary fix. Right? It provides immediate relief, but what are the pitfalls for that? So it's temporary relief. It increases the costs, and it leads to a little bit of downtime during migration. And most of the time, your applications might not be big to scale vertically or horizontally, like maybe horizontal, vertically less, but horizontally maybe not. So what are the things that they're not talking about when they say that, okay, add more servers or add more resources? We don't talk about which server to scale. So let's say you have an application. At max, always at or a bare minimum, you always have a database server and an application server, right? So which one do you scale? You scale both, or do you scale one? Right? So that's the first question that it never gets talked about. If you go to Google, nobody talks about it. So that's one question where you can put it. And horizontal scaling, right? So let's say you add more servers, and how do you distribute the load? How do you distribute the traffic? How do you distribute the load which is coming from one server to another? And then how do you maintain, let's say the request goes to one server, you save something in memory, right? So the user is doing some, let us say same user that the next request goes to another server. The two servers don't have context of something which previously was done by the user. So how you made sure that there's some shared information between the servers? And that's something which is also not usually talked about. So with multiple servers, how do you handle monitor? Let's say if a issue does come up, how you look at loss? That's something which you need to tackle again. And how do you monitor those logs? Also becomes pretty good to understand. And then the last question is, how do you sleep? Which is, let's say, is it just manually adding more servers, or there is something more? When do you add more servers? How do you know when to add more servers? So those are the questions. That's an awful lot of questions, yes, but then those are the questions that comes up if you actually sit and think about it, right? So with that, let's go step by step. Like I said, at the back you always have an application server and a database server. So which one do you scale? The database is also a server. It also uses CPU and RAM. So how do you decide which one needs to be scaled, right? So the keyword is bottleneck. Always look at what your bottlenecks are. So your database can be a bottleneck. And let's say your database is the bottleneck and you scale up or horizontal scale or add your servers for your application server. Like you scale your application server, but you not do anything to your database server. So what happens? Like there's more load on your database. It does not address, it will keep repeating the same error which probably it's going right now, or you're only able to add handle board requests. So your application, you not get the you're saying I'm adding more server, otherwise not solving my issue because you haven't scaled your database. So, but that was your bottleneck. So always understand what your bottleneck is. So what you need to ask yourself is my application process heavy, or is it be like that? So is my application spending more time processing a request, in which case you should scale your application or your code, the application, an application. So, but if let's say a loss that is likely to lean and write in to the database, then you should probably look at scaling your database and how you can optimize that. So just always remember key point. It's a bottleneck. You need to figure out what your bottlenecks are. Can be those, right? Sometimes. So a good idea is profiling. That's if anybody is taking notes, just do profiling on your application and figure out, is it process heavy or is it retry database heavy, and or they can be both in most cases. So just go in and check where your current bottlenecks are, how you can tap the path. All right. So this is going to get a little technical. So how do you go about look at the database first? Before you start adding more databases, you should probably look at how you can optimize some of the queries, database queries that you pick. So in most cases, we can either use something called as an API, or you can use a very simple tool which comes in most databases, which is XP and Analyze. So any query that you have, any database query that you might have, if you feel it's a very slow query, you can use something called XP Analytics, and it will give you, you can see an example below, which says unstacked to actually execute the program. So that will give you a very good idea in terms of how not very some queries take less time, but one queries take way too much time. Let's say 10 seconds. So how can I optimize that? So that will help you a lot more rather than actually adding more servers to it. So what you can do is, and we'll get into it a little bit more, is normalization or denormalization. So these are concepts of databases. So in this case, what you need to do is normalization is actually breaking down your existing, let's say your big T, right? So what happens with a database SQL query is, let's say you have a lot of columns and a lot of rows. We have a lot of fun that it's a lot of data. So it actually needs to put all of that and that give results back. So you can divide your tables into two. We'll look at that a little later. We'll get into the concepts about user U report. And then there is denormalization. That is the opposite of normalization, which is maybe you have data in too many queues. If you have used SQL, you might have to use something called join query at some given moment. So what you need to do is figure out, are there too many joins? Should I reduce that? Right. So you can denormalize your tables, which is that to actually improve your query performance. Query performance will have a better impact than actually scaling up your servers. Indexing. So indexing is key. Always index all of your queries, all of your tables. Should have tests. Always look at indexing. That's another point we can learn now. Indexing, we get to it. There's some tips and tricks that I'll be covering now. So if you want, you can take a screenshot of this at the end of it, which is align your where clauses based on the indexes that we match. So if you have written a SQL query, you always have select something where clause, right? So if let's say you're using a where clause, your where clause should be on your indexes and build your indexes based on this vectors. So let's say you always query something on a customer ID and a username. So you can have your indexes on customer ID and the username. So what does indexing actually do? It tells your database that I'm going to frequently always query on these two forms. So you can create some sort of a cache, or always keep the data handy and give you faster results, right? So that is something you should always look at. This indexing, 50% or 60% of the time will be better results than actually other stuff that you. Another thing, sometimes it gets missed in a lot of cases, is using a like query, but using a belt clause. Sometimes we tend to use percentage and the beginning and at the end of it of a like. So that actually invalidates your indexing. It does not check your indexes if you use that. Always use the percentage sign at the end of your string. But that would use it at the beginning. Otherwise, it skips the indexing and it does blank it. Like you might have indexes already in place, but you might be puzzled about why is this query take so much time. Another thing you can do is avoid or inquiries. Better to use union in between. And the last thing would be order by and where clause should align so that indexes are can use. So always align not where clause and order by and everything with the indexes that you have. Okay, a few more. Union or versus union. Union or is faster because it does not remove duplicates, whereas union does. And your indexes should be arranged. And repeating this is an important point, which is your indexes should always be on the where clause. Okay. And in most cases, if you have a joint query, use the larger table first in your where clause when you're putting your job query. So the second, the join, it should be on the larger table. For MySQL, it's the opposite. But for all the tables, you can add the lateral tier first. Okay. So we looked at optimized security, like optimizing your queries, the where clauses, your indexing, and how we can improve that. There's something called a connection buoy. What does connection buoy be? So whenever you're creating a database connection, what does it do? It opens an IO code, right? And it asks, like opening a connection to the database and then saying that, hey, I'm going to run queries, open socket, and it opens the top of socket, and then the read that right that all the query goes back and forth. What you can do is creating any network connection at any given point is an expensive process. Any IO operation which happens is an expensive process. You can take that as a note. So all we need to do always is how we can avoid any IO operation or any network, that socket opening operation, because that's always a very expensive operation. Like can we cater on 3 or 5 circuits. So always make sure what you can do to spool your connection. What does that mean? What if I know that, or what if you already know that, let's say you are has somewhere already to be, you are prepared in advance, right? So let's say you have to go somewhere and it's going to take some time, so you prepare yourself in advance. So we can do the same. We can keep some connection open all the time and cool them. That's the connection put purpose. So, and use those connections whenever it's required by the application. I don't have to build it or start connection every time. Build a new network connection every time a database needs to make a query. What you can do is just say, let me pool a bunch of connections, let me open a bunch of sockets already and just keep it handy. And then after that, I use or reuse those connections rather than actually, making a new connection each time, which gives a nice such process. The connection buoy, this one first screenshot. These are some libraries that help you with connection pooling based on different languages that you've. When I was that one more, I just covered those. So at it, sure of that. But then there's question of how many connections you need to, how many, like when you're doing your connection pooling, how many connections do you keep? So there's an ideal general rule, which should help you. It's the total available band minus the base memory divided by a split memory per connection that you want, which will give you a full number of connections that you should have for your application. Right. Okay. So we looked at connection pooling. We looked at optimizing our queries. So now we can look at something called read replicas. So even in database, we have two operations, right? We have a read operation, that we have a write operation. So what if yours, like I said, what if your application is read heavy or is it write heavy? So you can distinguish and then scale raws service upon it. So you can have something called read replicas, which helps you, because in most cases, write operations are less, but read operations are more. So you have something called read replicas. You can have different read replicas. And you can have just one master which does the write operation. In which case, you don't have to worry about. So you can have multiple servers which are all doing read, and you have each application server can connect to a read, which reduces the load on your read replica or your attack database. So there's something which is just write it to the database, and then there is read replicas which are actually just doing the read operation. In this scenario, what you need to take care of is replication, which means if you have a master learning, right, and it is, let's say, writing, you need to make sure your replicas have the same data at all the time, right? So that's the application is something which you need to look at. So that usually 3 types of replication: asynchronous, synchronous, and semi-sync. Asynchronous is the master saying, hey, okay, this is a commit which happened, and that's it. It does not wait for any sort of feedback from anywhere. It just says, okay, here this. Now it's up to the read replicas to actually, update their own database. Then there is a synchronous replication, which is it will actually wait. The master will actually wait for other read replicas to say that, yes, I have committed on the data. And then that's semi-sync, which is the master will just say, take, these are all the commits that you need to update. And then the read update is like, okay, I acknowledge I have received it, but then not actually, like in synchronous where it actually commits and then responds saying that, okay, I have committed all the data. But in this case, it just acknowledges that, okay, I have received it. And then that's it. So you need to figure out which application strategy works for you. If you have replicas that handles most or 80% of the cases, but then let's say you have a global scale application and you want to have multiple bytes. You can have multiple bytes, like you can have multiple masters, but then your application needs to support it. The only point that I'll cover here is please do not use auto-incremented IDs when you have two master application, because what happens is auto-incremented ID in one can conflict with another auto-incremented ID on another, and that's going to cause some conflicts. So you don't use IDs, use GUIs. That's a pattern use case. And that should probably I just go to when you have multiple masters, the application becomes even like with three replica, it's easier to handle, but with multiple masters, it's a headache. So you need to figure out, are the both masters in sync? They can be a sluggish performance because there's a lot of replication happening. This is also writing, this is also writing. They need to make sure that all the data is in sync. And conflict resolution becomes an issue. Like I said, if you use auto-incremented IDs, so that becomes a problem. What I recommend is what you should look at. There's something called partitioning and sharding, right? So what you can do, I think I talked about normalization and denormalization. This is a similar concept, which is vertical partitioning. If you have a large table, let's say you have users table, let's say you have tens and billions of records in your that makes small number for the database, but let's say you have. So what happens in a database, and let's say if you're searching for something, right? So it will scan through your entire table to find that particular particle. But let's say you had to manually search for a particular folder once a million folders, right? You're looking for one folder. So it takes time. But what if you had to only sort through 10 folders? It would take way less time, right? So let's say you're trying to find your keys among a bunch of keys. And if the key is, let's say it is this 3 keys, you know which one is yours. But let's say if you have 10,000 keys, it will take some time for you to figure out which key is which key is mine. So what you can do is you can partition your existing cables into different, so there are two kinds of partitioning. What you can do is you can, if let's say you have a lot of columns, we divide into two tables. You have a foreign key and then you have less data in one and the sub data in another. What you can also do is something called horizontal partitioning, which also is sharding, a keyboard distribution. But horizontal partitioning is you keep X number of rows in one table and X number, like the best in another table. And then you can divide it. That let's say you have 10,000 rows in each table, and the subtables can have all the rest. One issue with horizontal partitioning is trying to figure out how to get to your data. Which table has, which subtable has the exact data that you need. So that is something which you need to figure out, but there are libraries out there of database which help you with that. If you do this horizontal partitioning, but in a distributed way, let's say you have multiple database tables, multi-master, that comes sharding. Very big companies which have a lot of vehicle, like Facebook, Google, usually use these kinds of strategies in make sure that, a bunch of faculty buses, one of them, to make sure that the application is quick and it's not taking too much time looking at the data I get to use. Perfect. Another thing you should look at is something called caching. I think this is, I can't remember use. If you have not used it, use it. It creates a subset of data and puts it in fast access memory. And what it does is, let's say, it reduces the entire load on the database. So you're not scanning databases, you're scanning a fast memory, in-memory table, which can help you access data quicker. So what you can do is, let's say you have a users people, and you have one user which, you access the data for. You can put that data in a memory. And if it's being frequently accessed, you can access it from the cache rather than from the database. Unless something updates in the database, in which case you should then evaluate your cache and put the new data in your cache. So it reduces the operation, the read operations on logical uses, and the caching that you had taken. That's a little bit of few tips and tricks. You can take a photo of this at the night. So always cache data which is most frequently accessed but modified less. In science, we don't want your application to always keep invalidating your cache and adding new entries to your cache, because that does not make sense. It should probably always put data which is less frequently changed but more frequently accessed. Those are the data that should flash. Try avoid putting large data in the cache. Put only relevant data that is more frequently accessed, because that speeds up performance in terms of what data you get back. Choose the right caching strategy, and always make sure you understand when to evaluate the cache. If you start using cache like Redis or something editing, make sure you know when to evaluate your cache. Usually update or delete operation are the best times when you should evaluate your cache. Okay. Next is make sure to test other load to see because when you add cache, that's also add another layer. And always remember, anytime you add another layer, that becomes a problem that it comes with more complexities that you should have. Make sure sensitive information was not stored in cache as much as basic information you can store in cache. So use frameworks. There are a lot of frameworks. So various Spring Cache. If you're using Java, use Spring Cache. That will help you with a lot of assets of how you connect to your cache or to use cache and all of that. We looked at optimizing queries. We looked at how we can scale and know what to scale. We looked at weak replicas. We looked at the entire database, how we can prove that. We looked at caching and how that can help us reduce load on our database. Now the question comes is, let's say we have concept to scale. How to distribute the load? That's one of the questions which you ask. So let's say you have multiple servers. Which server the data books? So we use something called load balance, which automatically does that. So if you're using something like AWS or Azure, just use a input load balancing, and that would solve most of your issues. But the question that comes is, which load balance appropriate to use? So that becomes one of the key factors. So by default, the round robin is the way to. It just does not. It distributes the incoming requests sequentially or in a cycle. There's something called weighted round robin. That's an enhanced version of round robin, in which case you put weights. Like let's say one server is bigger in CPU and RAM compared to another server, so you can do a poor weightage, saying that most of the requests should go here and the other requests can come here. And then there is ID hash. You want to make sure that one request from one ID always goes to one server, so you can do that reason. So IP hash. Then there is those are mostly all static load balancing. There's something called dynamic load balancing, in which case it's more like the load balancer looks at which server has how many connections, what is the response time from each server, what resources are being used, and then based on that make a guess in terms of how the requests are being divided amongst the servers. So always make sure you understand your application and what works for your application. One thing you can also look at is IT or steady shot. So steady shot ticks is where let's say one user came and the request went to one site. You want to make sure that uses a body code to backs up and you can do snap or piece up. Okay. One thing you need to always look at is your application ready to support horizontal experiment? Which means, like I mentioned, if let's say a request goes to one server, for a particular user. You logged in, the session is there on that server. But now in the next request goes to another server. So now you need to make sure that that session that got created on the first server is shared between all of your servers. All right. So your application needs to support horizontal scale. You can't just switch, enable a switch and that horizontal scale can't. No, that's not. You have to figure out if your application select for it. So statelessness is something which you can do. Central management, as I mentioned, to think about why.
Avoid auto-implemented IEs and subordinate paralegals.
So that is something which you should look at. Let's figure out in terms of the next question we is how you scale your servers. When do you scale the servers and how do you scale your servers? So one thing you can do is we can monitor your performance. You can set up some alerts and then add servers manually if you want it. Or you can even automate them. I think many of us use, have used AWS or Azure, and they have something which you can use to actually, auto add both servers as and when needed. But then there's a general rule that always have a little bit to it. Otherwise, you might have n-1 servers without even realizing it. So always have alerts in place. Use some tools like these, which would probably help you monitor your application. And over a period of time, you'll understand when you to scale your application and when not to scale your application. Let's say yours is an e-commerce application, and there's a Black Friday going to come. So you can prepare beforehand for the load that is going to come. So how much of the load the servers can take. So you can add more servers of ID. So have alerts in place. Start with adding servers manually. And then after that, look at auto scale. So this is what I was talking about, where you can scale in or scale out based on your requirements. And you can feed that into your cloud platforms that are already there. And they're happy with scaling. So I talked a lot about everything but other than microservices. If they come to microservices, but I'm not going to touch with us all the time. Explain. There's this article, I'm not sure how many of you guys have there is. This is from engineer from Prime Video themselves. It says that microservices is not always the answer. Prime Video themselves, Amazon, they moved away from microservices and distributed systems to a monolithic one, to a single application, which actually helped improve and reduce costs by 90%. So it's always good to understand what works for your application. So I just touch upon microservices very briefly because I can get all into it. Yes, it does come up with its own challenges. Like how does one service talk to another service? How do you like if there's so many services, again, how do you manage your logs? How do you manage this key, distributed tracing, monitoring, end-to-end testing, and security? Let's say a user logged in one service. How do you make sure the user have access to the other service and then managing that?
A lot of complex incumbents start using the services,
but then have dedicated queues working on different services. So it does come up with like some benefits, but then it also adds more complexity. So yeah, jump to the report, but then if you get it or no.
So the point is, as summarized now, which is scalability is multifaceted.
And in my experience, what I've understood is it's not just handling more requests, it's also ensuring that your entire system can adapt to the increased load. It's not always about adding more servers, it's also about looking at your application pool and figuring out, it's not always the hardware, it's also looking at is your application and your code, had written back code can be the top of boxes. So look at your code. It's not always the hardware. Use the right tools. Use the tools that work for you. Something that works for you might not work for somebody else or some other application. And adding new stuff always has complexity, right? So when it's a continuous evolution, and with that, there's a new term which is going around. It's called managed services. I'm not sure. No. Yes. With that, I'm happy to take any questions.